Hello, welcome to Maths with EJD. In this video, I'll be taking another structured problem that is in three parts. The first part is to talk about what I understand by the term statistics. And then the second part, we'll write short notes on each of the following terms: measurement scales, hypotheses, data, parameters, and array. The third part, we'll construct a pie chart of the data given below. We have faculty and their population. Education faculty has 60,000 people, arts 52,000, sciences 45,000, and law 40,000. So we go on to take care of that. So let's start with the first part. What do you understand by statistics? That's A. And straight up, statistics is the branch of mathematics that deals with collecting, analyzing, interpreting, presenting, and organizing data. I think organizing should even come before presenting. So organizing and presenting data. Okay. It involves it involves various techniques to summarize data meaningfully, for that matter, meaningfully, then draw conclusions, and make predictions based on the patterns observed. So in practical applications, statistics helps to inform decisions in fields such as, like, so let's put education first, such as education, economics, medicine, social sciences, and engineering. In short, statistics is useful in almost every field. So that's the answer to the first part. What do you understand by the term statistics? So next we go to the short notes. So for that, I do this B now. First of all, we start with measurement skills. Measurement skills. Okay. And there we should know that measurement skills are categories used to classify and measure data. And there are four main types. So the first is the nominal scale. Nominal scale. So this is used for labeling variables. For labeling variables without quantitative value. Without quantitative value. So things like gender, gender, and color. Like that. Then we have what you can call the ordinal scale. Ordinal scale. So that represents order. It represents order or rank, but does not quantify, but does not quantify the difference between the ranks. Between the ranks. For instance, you can talk about movie ratings, movie ratings, or even music album ratings. The first and second, there's no particular there's no way to quantify, right? Maybe just have the first one has 30 streams. I mean, 3 million streams. The second may have 2 million streams, and the third one can now have like 500,000 streams. You can see that there's no representation that goes according to normal numbers. So that's ordinal. So you cannot really quantify the difference. That's the idea there. Then here you have the interval scale. Interval scale. So for the interval scale, it measures the difference. It measures the difference between values. However, it lacks a true zero. It lacks a true zero. So normally, right, zero should mean that something does not exist. But when you talk about temperature in Celsius, for instance, you know, when you say something is at 0 degrees Celsius, it doesn't mean that that thing does not exist. It only means that it is as cold as 0 degrees. So that's different from when you say the length of something is 0 meters. So when the length of something is 0 meter, that means it doesn't exist. So interval scale measures differences between values, right? But then it lacks true zero. So meaning lacking true zero means that the fact that it has zero doesn't mean that it has ceased to exist. So the zero just shows degree here. Then we have the last one, which is the ratio scale. The ratio scale actually contains all the features, all the features of an interval scale, but includes a true zero. It includes a true zero. So here, zero really means zero. Zero means that it doesn't exist. So allowing for meaningful comparisons, allowing for meaningful comparisons. So when there's no true zero, like in the case of temperature, you can't really compare per se. Allowing for a true comparison. So e.g., weight. So if you say something weighs 0 kg, that means the thing does not simply exist, so to speak. You know. So height, if you say something is 0 meter long, it doesn't just exist. Okay, so that's about measurement skills. Then we move on to, okay, that's the first thing we're writing about, measurement skills. Then we move on to number two, which is hypothesis. Hypothesis. Here, a hypothesis is a statement or proposition that can be tested through experimentation or observation. It is often formulated as a null hypothesis, H naught, suggesting no effect or relationship, no effect or relationship and an alternative hypothesis which you can usually call HA or H1 as you like, and this would indicating the presence of an effect or relationship. Okay, so that goes for number two, Roman figure two hypothesis. Then three, uh, you know, uh, measurements, measurement scales hypothesis. Data is the third thing, parameters for arrays five. So let's talk about data next. So data is number three. So what do we have to say about data? So we can say data are pieces of information collected through observations. Measurements or surveys. Okay. They can be qualitative. Data can be qualitative or categorical. It can be qualitative. Okay, they can be qualitative, which is also which means categorical, or they can be quantitative. Can be quantitative. That would mean they are numerical in nature, numerical in nature, and serve as the basis. They serve as the basis for statistical analysis. This is for statistical analysis. Okay, that's data for you. If you want to relate data and information, you say, I remember one layman definition we had back in the maybe in secondary school. So something like data is unprocessed information, while information is processed data. Okay, so when you get raw information, that's data. Then when you process it into something more meaningful, then you can say that is information. Okay. Then we have the next one talking about parameters. Parameters. So we can say that parameters are numerical values. They are numerical values that describe characteristics of a population, such as the mean. So the mean is a parameter, median is a parameter, or even mean, median, or even standard deviation. Standard deviation. So we say unlike statistics, I mean statistics in this sense is not in the general sense. Statistics are also values, but the only thing is that they're associated with samples, unlike statistics, which are derived. So the numerical values you get from samples are called statistics, while the one from populations are called parameters. So unlike statistics, which are derived from sample data, parameters, parameters represent the entire population. So parameters represent the entire population. So you have parameter for entire population, while you have statistics for sample for your sample data. So that's why you can say sample statistics and population parameters. So something like that. And then I go for the fifth one, talking about array. Array. Okay. We can say that an array in statistics. So array can have different meanings, right? Depending on the context. You can talk about it in computing. Of course, they have very close meanings. So an array in statistics is an ordered arrangement of data values. Ordered arrangement of data values. Like in spreadsheets where you have rows and columns, right? So ordered arrangement of data values. So organizing data into an array, can help to sort values and make statistical calculations easier. Make statistical calculations easier, such as finding the median or identifying the range. Okay, so we bring that to an end. So we are done with the first two parts. We are done with part A, part B. We are going to part C, where we have to construct a pie chart of the data given below. So let's go for the pie chart. That is part C now. So to construct a pie chart, we first need to calculate the degree of the sector, the degree of of the sector of a circle that each faculty population that each faculty's population. Okay, we first need to calculate the degree of the sector of a circle that each. Okay, let me say for each now. Let me say for each faculty's population relative to the total population, This is because a pie chart is you representing the magnitude of different data, its magnitude in a circle. So it means that everything you're going to represent is going to take a sector of the circle. So you have a circle, right? So depending on how big a particular thing is, so one can have this, the other one has this, the other one have this, and then you can even have smaller things like this. So it all depends. So the degree each one should take, that's what we need to do. We need to look for first, right? In some cases, people use percentages, but I think degree is more common. So let's go for all that we have. We have again, we have faculty, right? Let me do this. Faculty and population. Faculty, population. Okay, in fact, let me do it this way. Let me do it. I think this is a very smart way of doing it. I think this would really help. Faculty, population. So we'll just do everything in a table instead of having to, waste space. Faculty, population, and then we go for degree of sector. Degree of Yeah, degree of sector. Yeah, I think that's not a bad way to put it. Okay. So here we have the first faculty is education. Education with 60,000 people. Education with 60,000 population. 60,000. Then we have the next one is arts. Arts with 52,000 population. Then we have sciences. Sciences with 45,000 population. And lastly, we have law. Law has 40,000 population. Like that. So now to calculate the degree now, of course, before we do that, we need to find the total population. So we need the total. So we have total population That's the addition of all this population. The total population will be, of course, 60 plus 40 is already 100, right? 60 plus 40 is 100,000. Yeah, 60,000 plus 40,000 is 100,000. Yeah. Then we have 52 plus 45. That is 97,000. That's like 196,000 is the total population. 196,000 total population. Or if I do this again, this is 112 plus 45, 157 plus 40. That's 197,000. That's the total population, right? Yeah, I think that works. 197 is the total population. So the degree of the sector now can be calculated as here you have 60,000 divided by 197,000. 197,000. You know, a whole circle is a revolution. So the total angle is 360 degrees because it's a revolution. So you multiply this by 360 degrees. Whatever you get, you write it there. Then here you have 52,000 divided by 197,000. That's the total population times 360 degrees. You get the angle for the sector. Then next you have 45,000 rather, divided by 197,000. Okay, and that is 360 degrees. And lastly, you have 40,000 divided by 197,000 times 360 degrees. So that way you can know the magnitude of each sector, right? I mean the how large the sector that each of those things is going to occupy. So let's go ahead and do the computation. First of all, I want to double check the population because sometimes I just discover simple things become easy when you're on the spot. 62,000. I mean, difficult things become, I mean, simple things can become tricky, right? When you're on the spot, like performing in front of a class or something like that. So 60,000 plus 52,000 plus 45,000. Then when you're under in an exam condition too, you're also prone to making mistakes because so don't trust your brain too much. So use your calculator as much as possible. So you can be very sure of what you're doing. Yeah, 197,000 is correct, confirmed. So you want to double check because these things are simple. So it will be painful if you miss it because you trust yourself too much to do the calculations like that. So you can do them anyhow you want, but then double check to be sure you get your full points. So 60,000 divided by 197,000 is equal to uh is equal to this is 109. Okay, let me even change the color for emphasis. So this will be 109.6 degrees. Let's make it in one decimal place. And the next one is 52,000. So, like I keep saying, don't collect someone's calculator and get into the exam or you can get thrown off balance. So make sure you use a calculator you have been used to for a long time. 52,000 divided by 197 times 360 degrees. That will be 95.0 degrees. Then the next one is 45,000 divided by 197,000. 45, 45,000 divided by 197,000. That is 82.2 degrees. Then lastly, you have 40,000 divided by 197 times 360. That's 40,000. So that is 79.1. Okay. Or rather 73 point. Hmm, that's 73 point. Okay, let me just put it at 2 degrees. So it can balance off all that, right? So everything can be 360 degrees. So that is normally that's 73.09. So maybe if I take it to two decimal places, it will be better, but let me just put it this way. So now you've got the angle. So all you just need to do, you know, is to get okay, draw your circle. So after drawing the circle, of course, you are going to draw the circle with what are those things called now? Compass. Yeah, it's better. I mean, you need a mathematical set, sincerely, if you want to get it accurately. So you draw with what did I just mention that thing? Compass, right? So you draw with compass, of course, you go to the center. So from the center, draw a line to any side of the circle. And from there, you can now start measuring the angles. So the first one is 109.6 degrees. So, something like this is like 90 degrees. So you can extend it a bit. So this is not perfect, please. So I'm just trying. And I'm still going to show you something perfect. If I had all the tools, I can do a perfect one. So this is 109.6 degrees. And that is where you have education. You have education there. Then the next thing is okay, one way you can know how you're going is so the next one you have is 95 degrees. 95 degrees is also more than 90 degrees. So from this line now, you know, coming this way is like 90 degrees. So you can extend it just a bit and you have 95 degrees. And that is for arts. That's for arts. And then the other one is sciences, which is 82.8 degrees. And then the last one is 73.2. So, obviously 82.2 is bigger than 73.2. So you can have, so and you just have that thing left for only two of them. So you can take the larger share. Maybe that's too large. Um, Something like this. So you can do it accurately. So this is 82.2 degrees, 82.2 degrees. And that is for sciences. That is for sciences. And then lastly, you have, of course, automatically whatever is left should be 73.2 for law. That's 73.2 degrees for law. Okay. But then I always like to give you the very best. So let me show you using Python. I was able to draw this. Okay, let me just do this. Clear all outputs and run it again. Okay. So I mean here, just declare the faculties, education, art, sciences, and law. The population 60,000, 52,000, 45,000, 40,000. And then you know, you're going to do calculations. Guess I've removed that here. So you're going to do some calculations. Okay, yeah, not even necessary. So you just do, I mean, it has a standard code. With that now you can see the biggest one is education, followed by arts, followed by sciences, followed by law. So the direction doesn't matter. Just make sure you label it correctly. That's all. So with this, we come to the end of this particular set of structured problem. And see you on the next one. If you have not subscribed to this channel, you want to do that right now because there's a whole lot to learn here and you'll be very glad. Then, of course, hit the notification button, notification bell, so you can always get notified each time I go live or each time I upload a new video. And don't forget to like, very important. Then comment, tell me if you want me to teach a topic or solve a problem, and share also so that more people can benefit from all the great learning going on here. Till I come your way again, keep crunching the numbers up and keep getting things right. See you. Bye.